Hey yo, what's up, YouTube? It's your boy JOSHABRAHAM. Oh, why is it going here? Here. Stay here, boy. Stay here. And we're gonna start with the assignment. Continue with the assignment. Yeah. Whoa. Let me pull up Clonopin Commander if he's here. Oh, bro, fuck this. Yeah, it's all good. Okay. So where was I last time? Input file, output file. Yeah, that's about it. Oh. Come on, don't hide. I got to here. Now, how do I continue? Come on, don't hide. Step 1, fix the indentation logic. Mm-hmm. Okay, I'll do the indentation logic. Yeah, that's the one. Hey Siri, set a timer for 1 hour. I'll give you two reference codes and tell me how each of them approached to solve the problem. Where's the headphone? Don't have. Don't have. The internet is so slow that YouTube is not loading. Where is the code? Yes, there we go. Can I just put it here? No. I need to bring it to duplicate. Duplicate goes to wait. What the fuck is this? A3. Yeah. Downloads back. Do we have that here now? A3. Oh yeah. That's the one. That's the one. That's the one. Copy. Mm-hmm. This is another one. Damn, that's a big boy. Fuck me, bro. Copy name. Uh, should make a file name reference, but not right now. Add .py file. Paste. Come on. What? A3. Okay. It's a big one. What the? 151 page lines. I need to change internally. These two would be reference codes. Scan. That was copy. Go down. Second code is more advanced, subject-oriented version of the same problem. Object-oriented uses classes. Genetic code stored as a simple dictionary stored with detailed info, abbreviation, one letter code type. Uh-huh. Code on handling. It's easier to explain and understand. It's simpler and still satisfies. Second version, object-oriented is cleaner, more professional, but requires understanding of class methods, items, object initialization. If your instructions allow either, what if you have to make one? The GPT reference code, how does this one works? Okay, all of these work, but how much lines of code did you have? 98, 200, 151. I think it's 98. What the so what are we doing here? Function to read multifaceted file. Read faster file, read the multifaceted file and returns to dictionary of sequences. Sequences equals it's not matrix, it's something else. With open, file path rsf, header equals none, line equals line dot strip. If line starts with this, it gets the header line 1. Sequence header equals else sequence header plus line in uppercase. Okay, let me see what we got as See assignment now. Test sequence. So return the sequences now define is valid DNA. It checks if sequence contains only ATGC. Check if sequences contains only ATGC. Valid basis. Check if sequences contain only ATG and C. Valid basis ATGC. Return sequence dot is subset valid basis. Check for valid DNA. If we're gonna. Okay, transcription DNA to mRNA. Define transcribed DNA to mRNA. 3 dash 5 dash. Oh, what? This one would be in. Write up takes DNA sequence in 5 dash to 3 dash direction from an input file. So, according to the question, the DNA is in 5 dash to 3 dash. I'm sorry, brother. Brother, we gotta make a difference up there. Whoa, what the What is this question actually? The program takes DNA sequence but also performs transcription considering the sequences as template strand. That means sequence in the file is written in 5 to 3 direction, but it represents the template DNA strand. Transcription happens on the template strand, producing mRNA that's complementary and reversed. Given gives, let's say the input as okay, when transcribed, mRNA is complementary, but the RNA grows in 5 to 3 direction, and DNA templates is read 3 to 5 You must reverse the strand first after completing. You must reverse the strand after completing. So the resulting mRNA Okay, yeah, I get that. The mRNA that you get from this would be 3 dash to 5 dash, but you have to reverse it to get it in the reading format. Oh, that's what this -1 does. Okay, okay. This part. I I don't think the question provided this. So how did you come up with this? I told you stop glazing, right? Except for rare. Okay, we choose variants. So you expected to use this universal mapping. Okay, okay. Phenylalanine, phenyl, phenylalam, phenylaline, laline. Okay, now define, translate mRNA to protein. mRNA sequence translates the mRNA sequences into amino acids, one letter codon. Mm-hmm. Protein, leave a space, start with mRNA sequence dot find. AUG. Okay, if AUG is only there, you should start. If start equals -1, no start codon found. For I in range start, length of mRNA, 3. Codon equals, that's like the starting and ending. If length of codon is less than 3, break. Amino acid, oh, okay. Amino acid equals codon table. So these all have R. That's weird. Amino acid equals codon table dot dead codon. If amino acid equals stop, break. Else, if amino acid protein at the protein part, main program sequences equals read faster. Input file when open as for name DNA sequence and sequence items. If not valid DNA sequence out dot write name input valid DNA. Continue. mRNA sequence equals transcribe DNA to mRNA. Protein sequence equals translate mRNA to protein. What? Okay. Okay. If I wanna run this, how do I start? No, no. I named this one GPT reference dot py, the one the .py file is in and the FASTA yeah. The name of okay, this should work. Oh Lord. Allow. Output file should be there? No. That's my sample output. Where's copy, bro? Oh, it's there. Okay, 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 I get it. Mm-hmm. DNA sequence, RNA sequence, AA sequence. Is that how the uh is that what I should be going for? Sequence 1. Mm-hmm. Okay, I got the output file. Now, now I wanna run this. And this one. Okay, now right now. No. If clone open commander was right, I think I should be able to do this, right? And no. uh, you don't owe me. I'm not just one of your wayward. You don't owe me. No. Mhm. Oh shit, okay. Results for sequence 1, results for... Okay. Copy. The difference is a difference in amino acid. Difference comes to DNA being read, transcribed, and how to start how to fix it. Bring the mRNA sequence generator from compare between your code and the reference. Make sure the reading frame starts with AUG. Some okay. Somebody made a mistake. Now let's run this one. Something must have happened. Oh, only one output text. I haven't seen. It's just down here? No. Uh-huh. Oh, it's in downloads right now. Okay. Oh, it's on downloads. Is that what you say? No, downloads don't have either. Okay, we got an output text. Now, to find out why me. Come on, come on, come on. This means logic is consistent and correctly transcribes the DNA. It's a different transcription or translation logic, which is output. Might not reverse the DNA for transcription. It might handle codons differently, example translation at the wrong place or ignoring the stop codons. Okay. Looks like I'll try. Okay, what's the next question? Right now, first, I don't want to repeat the same mistake last time. First, find out all the stuff you need to know. Is about blossom matrix, which are substituent matrices used in bioinformatics to score alignments or sequence a small multiple sequence alignment, alphabet A, B, 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 so nucleotide. So nucleotides, not amino acid. You're asked to compute blossom 100 and blossom 75. Compare, understand blossom matrices. Blossom block substitution matrix gives a score for substituting one residue for another. They are derived from blocks of aligned sequences looking for absurd substitution. Blossom 100, very strict. Sequences must be 100% identical or nearly identical to be considered in a computation. Blossom 75, more permissive. Sequences can differ up to 25%. So Blossom 100 will have higher scores for matches and harsher penalties for mismatches. Blossom 75 allows more variation, so mismatches are penalized less. Count pairwise substitute. Just a minute. Just a minute. Count pairwise substitution, column 1. What? Pairs, okay. What? For each column in your alignment, count all pairwise matches and mismatches. For example, column 1. Column 1, pairs. A pair, just one. Wait, oh, say, oh, one, two, like, three, five, okay. One, two, where's the two? One, three, one, two, one, three, one, four. No? Columns, right? Columns, downwards. One, two, one, three, one, four. Why is, oh, five mismatch. Okay. Do this for all the pairs. You'll get accounts of, okay. Then compute the frequencies. Observed probability, the number of times residue X is aligned with residue Y divided by the total pairs. Expected probability is the product of something, product of the frequencies of X and Y in the data set. Compute the log odds score. Blossom score is log 2px5 qx qy. Positive score, substitution observed more than by chance, likely conserved. Negative scores, substitution observed less often, rare, penalized. Penalized. Negative scores, substitution observed less often, rare and penalized. Oh, okay, that's the expected probability. That's a product of frequencies of. Now, if we're talking frequency, are these frequencies? I kind of understand. Okay, positive score, substitution observed more often than by chance. Negative score, substitution observed less often, rare and penalized. Applying clustering threshold, Blossom 100 keeps only sequences. Just a minute. I gotta play some music. Bam, 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 bam. Once you have all the scores for all pairs, you can fill in the 4x4 matrix. Diagonal, more match scores, usually positive. Off diagonal, mismatch scores, negative or smaller. Compare Blossom 100 versus Blossom 75. High match scores, severe mismatch penalties. Lower match scores, milder mismatch penalties. Interpretation. Blossom 100 is better for closely related sequences. Okay, I kinda understood what I should be doing. I'm gonna end the stream. I'll continue with biochemical kinetics because it's about 1 hour. I was planning to change subjects after 1 hour. Well, we gotta be better. We gotta be better, stronger, smarter, faster. Every bullshit out there. Yeah. Peace.